to S.V.I.M Institute of Mathematics YouTube channel. So after long back, I am going to take again the classes in mathematics, but already we had started similar triangles of chapter in mathematics of 10th class syllabus. Now in exercise 8.1, 3 problems had been completed in previous classes. Now I am going to start from 4th problem. So once again, welcome to S.V.I.M channel. మనకు ఈ హాలిడేస్ కారణంగా నేను కొంత అందుబాటులో లేకుండా ఉండటం జరిగింది. ఇప్పటి నుండి మళ్ళీ వీడియో పెట్టాలని ప్లాన్ చేశాను. కంపల్సరీ వీడియోస్ పెడుతూ వస్తాను. మీరు లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. బెల్ బటన్ కూడా మీరు నొక్కినట్లయితే నేను పెట్టిన ప్రతి వీడియో కూడా మీకు ఒక ఇండికేషన్ ఇస్తూ రావడం జరుగుతుంది. సో ఇప్పటి నుంచి కంటిన్యూగా క్లాసులు జరుగుతాయి అనే ఆ విషయాన్ని కూడా ప్రేక్షకులకి తెలియజేస్తున్నాను. ఓకేనా? సో ఇక్కడ నేను బోర్డు పైన 4th ప్రాబ్లం 5th ప్రాబ్లం రాయటం జరిగింది. లెట్ మీ రీడ్ దట్ 4th ప్రాబ్లం అండ్ ఆల్సో నీడ్ టు అబ్జర్వ్ వాట్ ఈస్ ద సొల్యూషన్ ఆఫ్ దట్ 4th ప్రాబ్లం. లిసన్ టు మీ. హియర్ ప్రూవ్ దట్ a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. So here what is given and what is we need to prove, that one you need to segregate. Now listen to me. Prove that a line drawn through the midpoint of one side of triangle. So in a triangle here one line is there. That line is we are taking from midpoint of one side of that triangle. The line which you are taking in that way, that is parallel to another side. So the line which you are taking from midpoint of one side, that is parallel to one more side. From here we have been given in the problem. The next part we need to prove ourselves. So what is we need to prove? Bisects the third side. That means in this way the line which you are taking that bisects the third side. Actually a triangle has 3 sides. In these 3 sides one line you need to take midpoint of one side, that should be parallel to second side. So whenever you are taking a line through the midpoint of one side is parallel to second side, then that line can divide the third side equally. That one we need to prove. So now listen to me. Here I am taking a triangle. The triangle of name here I am taking as PQR. PQR is a triangle. So here what are the 3 sides here? PQ, QR, PR. These are the 3 sides. In these 3 sides we need to take one midpoint for any one of the 3 sides. So for PQ I am taking a midpoint. That midpoint I am taking here as A. From this midpoint you need to take a line. So if you want to take a line from this midpoint, automatically must you need to take the line in this way. So the line which you are taking from this midpoint of this side PQ, that is parallel to which side? Surely it is parallel to QR. Yes, it is parallel to QR. But the line which you are taking in this way, that can meet the side PR in one more point. That point here I am assuming as B. That's all. So here in this triangle, this is midpoint of this side, and the line which you are taking from the midpoint of this side is parallel to QR. That's all. From here we have been given in the problem. But what we need to prove here means the line which you are taking in this way, that can bisect the third side. So here what is the third side? From this side we are taking, from this midpoint of this side we are taking the line that is parallel to the second side. 2 sides have been over in the triangle. And what is the third side? The third side here is nothing but PR. So the line which you are taking in this way, that can bisect this third side PR. That one we need to prove. That's all. So first of all you need to write given. What is the given information? In triangle PQR, in triangle PQR, A is the midpoint of the side. The midpoint of the side PQ. That's all. Some more information you are giving here. What is that some more information? Listen to me. From this midpoint, the line which you are taking, that is parallel to QR. Yes. The line which is taking from midpoint of the side PQ is parallel to QR. That's all. Simply we can write A is midpoint of PQ and AB is parallel to, for which side? QR. This is you have been given in the problem. But what we need to prove here, required to prove AB bisects the third side of triangle PQR. What is the third side? PR. That's all. That means simply PB equal to BR. Like in that way, if you prove, automatically that line bisects the third side of the triangle. PB is equal to BR. That one we need to prove. Now listen to me. Proof. Take it here. A is the midpoint of PQ. A is the midpoint of PQ. That is, it has been given in the problem. That's all. So how can you write A is the midpoint of PQ means PA is equal to AQ. PA is equal to AQ. So here, this PA we can write as 1 into PA and this AQ also we can write as 1 into AQ. That's why I am taking that PA is equal to AQ into 1. Now listen to me, PA. Next here, from this 1, just I am sending this AQ to another side of equality symbol. Then it will be changed as by AQ. That is equal to 1. That's all. Next, after that, listen to me. Here AB is parallel to QR. AB is parallel to QR. This is also you have been given in the problem. Already we know the concept of Thales theorem. What is the concept of that Thales theorem? In a triangle, if a line or line segment is parallel to any one of the 3 sides of the triangle, that can bisect the remaining 2 sides. This is concept of the Thales theorem. According to that concept, here you can write PA by AB is AQ is equal to PB by BR. Yes, simply according to basic proportionality theorem, how can you write PA by AQ is equal to PB by BR. Okay. Now here listen to me. PA by AQ is equal to 1. Here we are getting that one. You can take as equation 1. That equation 1 you need to substitute in equation 2. That's why this equation you need to assume as equation 2. So now equation 1 in equation 2. Now equation 2 implies 2. In PA by AQ, we need to write its value, that is 1. That is equal to PB by BR. Yes, by sending this divided by BR to another side of equality symbol, it will be changed as 1 into BR is equal to PB. So simply, this one you can write as PB is equal to BR. Now listen to me. PB is equal to BR means B is midpoint of PR. Implies to B is midpoint of, what is it? PR implies 2. Now we can say AB bisects PR implies to AB bisects PR. Hence proved. That's all. Okay. Yes. Next, one more problem we are having here. That is fifth problem. Okay. Yes. Let me explain that fifth problem. First of all, you need to read the question which you have been given in the problem. That is, do that a line joining the midpoints of any two sides of triangle. So here, a triangle you need to take. Automatically, three sides we are having. In a triangle. In this three sides, any two sides you need to select. For these two sides, you need to mark two midpoints. After taking two midpoints of two sides, we need to draw a line through the two midpoints of these two sides. The line segment which you have been taken in that way, that is parallel to third side of the triangle. That one we need to prove. First of all, whatever it is have been given the theorem in the problem, first we need to segregate which have been given in the problem and which one we need to prove. The two parts we need to separate. Here, a triangle have been given. After that, two sides of midpoints also have been given, and a line segment also we need to draw from these two midpoints of two sides. From here, you have been given in the problem. After that, the information which you are having here, that one we need to prove. So here, two sides had been over. By taking two midpoints of the two sides also had been over. The line segment you are taking, which is from two midpoints of two sides, had been also over. The line segment which you have been taken in that way, that is parallel to third side. That one we need to prove. That's all. So now listen to me. Let me draw a triangle. The name of the triangle here I am taking as ABC. The three sides of this triangle are nothing but AB, BC, AC. For any 2 points, you need to take two midpoints. So here I am taking two sides AB and AC. AB of midpoint I am taking here as D, and AC of midpoint here I am taking as E. So D and E are the midpoints of the sides AB and AC. That's all. Now we need to draw a line segment by joining these two midpoints. In that way, the line segment which you are getting, that is D, that is parallel to third side of that triangle. Two sides already have been taken. The remaining side is nothing but third side here. What is that third side here? BC. The line segment which you are taking in this way, DE, that is parallel to BC. This one we need to prove. That's all. So here I am writing the given information. In triangle ABC, D and E are the midpoints of the sides AB and AC. That's all. Okay. Now required to prove. Line segment joined by the midpoints D and E is parallel to third side of the triangle ABC. That means here simply we need to prove D is parallel to BC. That's all. Now proof. Okay. Now listen to it. D is midpoint of the side AB. That is given. Next, D is midpoint of AB means AD is equal to DB. Like in that way, we may write AD is equal to DB. Here, 1 into AD equal to 1 into DB. Like in that way, also you can write, or AD equal to DB into 1. In that way, also you can write this equation. Now I am sending this DB to another side of equality symbol. Now it will be changed as AD by DB. That is equal to 1. This equation I am taking as 1. Next, after that, E is midpoint of the side AC. This is also you have been given. Now listen to me. E is the midpoint of AC means AE is equal to EC. Like in that way, we may write AE is equal to EC and EC into 1 also we can create. Now I am sending this EC to another side of equality symbol. It will be changed as division. That means AE by EC is equal to 1. This equation I am taking as 2. In these two equations, their respective right hand sides are equal. According to that, we may equal their respective left hand sides. So from 1 and 2, from 1 and 2, this RHS of respective left hand side part is AD by DB. That is equal to the second equation of RHS. Its respect to left hand side part is AE by EC. Now we need to check this ratio in the problem. AD by DB is equal to AE by EC. So here, this is nothing but concept of converse basic proportionality theorem. What is that concept of basic proportionality theorem? Converse of basic proportionality theorem. In a triangle, if two sides have been divided in the same ratio by a line or line segment, then that line or line segment is parallel to third side of the triangle. This is the concept of converse of basic proportionality theorem. Simply you can write according to converse of BPT. How can you write? DE is parallel to BC. That one we need to prove. Hence, prove. That's it. So here, today also, I planned to solve some more problems. So keep these problems in your notebooks. Okay? Thank you. Welcome back to sixth problem. Let me read the problem. In the given figure, this is the given figure. As D is parallel to OQ. Just see this formation located in which place in the given figure. DE. So this is DE. That is parallel to OQ. That means this DE is parallel to OQ. Here we need to take this triangle. That idea we need to get. Because of DE is parallel to OQ means must and should we need to consider this triangle. That's all. This idea you need to keep one side at in your mind. After that, and DF is parallel to OR. So this is the DF line segment that is parallel to what? OR. So here also we need to consider which triangle? Triangle POR. That's all. Okay, keep it aside. Next, but here we need to prove EF is parallel to QR. Where is EF? This EF is parallel to QR. Here we need to observe one thing. By taking these two sides of parallel concept and by taking these two sides of parallel concept, we need to prove EF is parallel to QR. It is very clear to us. To prove EF is parallel to QR, these two parallel concepts are nothing but clues. By using them, we need to prove EF is parallel to QR. That's all. So now listen to me. In triangle PQR, given DE is parallel to OQ. Now we need to consider the triangle POQ. That's all. In a triangle, if a line or line segment is parallel to any one of the three sides of that triangle, then that line can divide the remaining two sides in the same ratio. This is basic proportionality theorem. So, according to basic proportionality theorem, how can you write PE by EQ is equal to PD by D. PD by D. This one I am taking as equation 1. Next, second clue now we need to consider. What is that second clue? Clue means DF is parallel to OR. Okay? So, given DF is parallel to OR. Yes. Now we need to consider the triangle. What is it? DF is parallel to OR. When you have been given these two lines are parallel or sides are parallel, now it is very clear to us to consider this triangle. What is the triangle? POR. POR. Now listen to me. In a triangle, if a line or line segment is parallel to any one of the three sides of the triangle, according to basic proportionality theorem, the line segment can divide the remaining two sides in the same ratio. According to basic proportionality theorem. So again, according to basic proportionality theorem, how can you write PD by DO is equal to PF by FR. PF by FR. This is equation 2. Now we need to observe these two equations. Listen to me. PE by EQ is equal to PD by DO. In second equation, that PD by DO is equal to for PF by FR. So from 1 and 2, PE by EQ is equal to for what? PD by DO. In second equation, that PD by DO is equal to for what? PF by FR. Now here I am taking PE by EQ is equal to PF by FR. This ratio we need to check where you are getting in the triangle. How you are getting that ratio in the triangle, we need to check. PE by EQ, where that is PE by EQ. That is equal to for what? PF by FR. That means in this triangle, these two line segments have been divided by the line segment EF in the same ratio. Then the line segment is parallel to the third side of that triangle. According to which property? Converse of basic proportionality theorem. That's all. So according to according to converse of basic proportionality theorem. How can you write that? Means listen to me one more time. In this triangle we are getting E by EQ is equal to PF by F1. So actually we are having a concept that is converse of basic proportionality theorem. What is that? In a triangle, if two line segments have been divided in the same ratio by a line segment, that line segment is parallel to third side of the triangle. That's all. So EF is parallel to QR. EF is parallel to QR. That's all. So actually we need to prove that one. EF is parallel to QR. Hence proved. Hence proved. That's all. Let me explain the next problem. That is seventh one. Okay? Keep watching. Welcome back to the problems 7th and 8th. Let me read the problem in 7. That is in the adjacent figure. This is the figure we have been given in the problem. In this figure, A, B and C are points on OP, OQ and OR. So this is OP. On this OP, A is a point. On this OQ, B is a point. On this OR, C is a point. This information you have been given from here to up to here. Next after that, but how we are taking that points means AB is parallel to PQ. This AB is parallel to PQ and AC is parallel to PR. These information we have been given, but here we need to show that BC is parallel to QR. This BC is parallel to QR. This concept we need to prove. That's all. So here listen to me. First I am writing the given information. Now listen to me. A is a point on PQ, OP. B is a point on OQ. C is a point on OR. This is you have been given. Additionally, AB is parallel to PQ. Here we need to get one idea. When AB is parallel to PQ, then we need to take the triangle OPQ. That's all. Next, AC is parallel to PR. This information also you have been given. Whenever after taking this information, what is that? AC is parallel to PR. Here also we need to get one idea. Now we need to consider the triangle POR. That's all. In this triangle, this line is parallel to any one of the three sides of the triangle. According to basic proportionality theorem, the line which you are taking in that way can divide the remaining two sides in the same ratio. According to basic proportionality theorem. That means here we can write OA is equal to AP. OA by AP is equal to OB by OQ. Like in that way, good light. Next here, AC is parallel to PR have been given. For that we can consider the triangle here POR. In this triangle, if a line or line segment is parallel to any one of the three sides of the triangle, that line can divide the remaining two sides in the same ratio. According to basic proportionality theorem. According to this, we can write OA by AP is equal to OC by CR. After writing these two equations, it is very easy to prove BC is parallel to QR. Let me write that information. Given in triangle OPQ, in this triangle OPQ, you have been given AB is parallel to PQ. AB is parallel to PQ. According to basic proportionality theorem, OA by AB is equal to OB by BQ. This is I am taking as equation 1. Next, now in triangle, now I am taking this triangle. Why you are taking this triangle means in the problem you have been given AC is parallel to PR. That's why we need to consider this triangle. What is the triangle? POR. In triangle POR, what is the information you have been given there? AC is parallel to PR. Again, according to BPT. Again, according to basic proportionality theorem. How can you write? With the two. OA by AB is equal to OC by PR. This is equation 2. From these two equations, here if you observe, in these two equations their respective left hand side parts are equal. Now we can write their respective right hand side parts are as equal. So from 1 and 2, this equation of right hand side part OB by BQ is equal to second equation of right hand side part, that is OC by CR. Listen, what we are getting here, that's what we need to set in the given figure. OB by BQ, OB by BQ is equal to OC by CR. Whenever you are having OB by BQ is equal to OC by CR, it is very clear to us to consider triangle ROQ or QOR. In this triangle, by this BC, these two line segments have been divided into same ratio. According to converse of basic proportionality theorem, in the line segment, that means according to which line, these two line segments of triangle have been divided in that way, that line is parallel to third side of that triangle. According to which concept? Converse of basic proportionality theorem. Okay, simply we can write here, according to converse of basic proportionality theorem. Why you are applying basic proportionality theorem means, in a triangle, if a line or line segment dividing any two sides of the triangle in the same ratio, then that line or line segment is parallel to third side of that triangle. So here BC is dividing OQ and OR sides of this triangle in the same ratio. That's why this BC is parallel to QR. According to which concept we may write that one? According to converse of basic proportionality theorem. It had been written here. So now simply BC is parallel to QR. But actually we need to prove that one BC is parallel to QR. Hence proved. That's all. One more problem we are having here, that is 8th one. Let me read that question. ABCD is a trapezium in which AB is parallel to DC. So AB and DC, these two are opposite sides. The two sides we need to take as parallel to each other, and its diagonals intersect each other at a point O. So actually two diagonals we have in a trapezium. The two diagonals are meeting each other at O. In which way they are meeting? No. But here we need to prove AO by BO equal to CO by BO. Let me draw the figure. A trapezium. This is a trapezium. In this trapezium, AB is parallel to DC. In that way only we need to take the trapezium. So A, B, C, D. Now this AB is parallel to CD. That's all. Next, diagonals are meet each other at O. This is a diagonal AC and this is one more diagonal of this trapezium ABC, that is BD. These two diagonals are meet each other at where? O. That's all. Here we need to prove AO by BO equal to CO by BO. Now listen to me. Here first given information, ABCD is a trapezium. ABCD is a trapezium. Next, AB is parallel to CD, comma, diagonals AC and BD or meet each other at. This is the given information, but required to prove. What we need to prove here means this one. AO by BO is equal to CO by DO. Yes. Here, so many times this type of theorem we are getting in this chapter. Here we need to construct something. The concept which we are going to write here, that one we need to keep in your mind. Always you need to remember when you are seeing this type of problem. What is that construction means? Here, through O, a line segment we need to consider that should be parallel to either AB or C. If you take that line segment is parallel to AB, automatically that is also parallel to CD. Because of this is trapezium and AB is parallel to CD, like in that way you have been given in the problem. Whenever the line segment which you are taking is parallel to AB, then it is also parallel to CD. The line segment which you are taking through O, that line segment here I am taking as X, that means OX. OX is parallel to AB. This is construction. Let OX is parallel to AB implies 2. How can you write that OX is also parallel to CD? Why AB is parallel to CD? AB is parallel to CD. That's all. Okay. Now I am coming to the proof. Listen to me. Here OX is parallel to AB. Whenever you are taking this OX, a line segment is parallel to AB. Now we need to consider this triangle. What is that? Triangle ADB. In a triangle, if a line segment is parallel to any one of the three sides of that triangle, then that line segment can divide the remaining two sides in the same ratio. According to which concept? Basic proportionality theorem. Yes, OX is parallel to AB. Now, in triangle ADB, according to basic proportionality theorem, how can you write? Listen to me. These two lines are parallel. The vertex which is opposite to them, that means D. From this vertex we need to consider the ratio. That means dx by xa, dx by dxa is equal to do by o. Do by o. This one I am taking as equation 1. Let me clear the board for the previous problem. Yes, now listen. So here, to get this equation 1, we are taking OX is parallel to AB. Okay? One more equation you need to take. By taking this OX is parallel to CD. Whenever you are taking this OX is parallel to CD, now we need to consider this triangle. What is that? Triangle ACD. Okay? Now, let OX is parallel to for what now? CD. OX is parallel to CD. Now we need to consider the triangle. What is that? ACD. In this triangle, listen to me. In this triangle, a line segment is parallel to any one of the three sides of the triangle. According to basic proportionality theorem, that line segment can divide the remaining two sides in the same ratio. What is according to which concept that is we are taking? That means according to basic proportionality theorem. So according to basic proportionality theorem in this triangle. Okay, these two lines are parallel. The vertex which is opposite to these two parallels in this triangle, from this vertex we need to consider the ratio. That means AX by XD. AX by XD is equal to AO by OC. AO by OC. Yes. Now listen to me. Here actually dx by xc we are having, but here ax by xc. To make the two equations of either LHS parts or RHS parts equal, we need to take both sides reciprocals of them. So by taking the reciprocals, this one we can write as xd by ax is equal to oc by AO. So here reason, by taking reciprocals on both sides. That's all. Now we can take this equation as 2. Now we need to observe these two equations. Here AC or dx both are same. xd by ax is equal to for what here? oc by AO. The same xd by ax in this equation is equal to for do by OB. That means in these two equations, left hand side parts are equal. Here we can write the respective right hand side parts are equal. From 1 and 2, how can you write? OC by AO is equal to for what? DO by OB. So what we need to prove here? AO by DO. AO by DO. So now listen to me. This AO I am sending to another side of equality symbol. It will be changed as AO by DO. This DO we need to send another side of equality symbol. Then it will be changed as division. That means OC constantly we need to write as it is here. This DO by sending to another side of equality symbol, it will locate here the place. Is equal to by OB we need to write as is here. Now here OA I am sending to other side of equality symbol, it can locate the place here. That's all. Now listen to me, AO by BO is equal to CO by DO. It has been proved now, but you can write AO by OB is equal to OC by DO. Hence, that's it. So here 8 problems have been completed in exercise 8.1. Just we are having one more problem, the last problem for this exercise. I can explain that problem in the next class. Okay, keep watching S.V.I.M channel. So ఈ S.V.I.M channel అబ్జర్వ్ చేసే మ్యాథమెటిక్స్ స్టూడెంట్స్ అందరూ షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. మీ ఫ్రెండ్స్ ఎవరైనా ఉన్నా కూడా చెప్పి సబ్స్క్రైబ్ చేయించండి. 10th క్లాస్ అయిపోయే లోపల మ్యాక్సిమం సిలబస్ నేను వీడియోస్ ద్వారా పెట్టాలనే ప్లాన్ చేసుకుంటున్నాను. సో మీరు కానీ కోఆపరేట్ చేసినట్లయితే ఖచ్చితంగా సక్సెస్ఫుల్గా విత్ ఇన్ ద 2 months before for conducting a public examination, I will try my level best to complete the syllabus. Okay, keep watching S.V.I.M channel. Thank you.